Esther, are you following along with the slides on your own machine, or are you going to be looking up here? What are you going to do?
I think I'll just look up there.
Look up there. I like that, because then I know that we're on the same page. Okay, so so this week we are shifting gears from mapping. Well, sorry, we haven't done mapping yet. Well, we did a little mapping in Socrata. Remember? Point maps and heat maps. So we're shifting gears from analyzing data mainly within this sort of table form, right? Socrata and Google Sheets, into the form of a map. But I want to, using a particular software called Carto. So essentially we're taking some of the same data that we've worked with, and we're now adding the spatial dimension to it. Not by adding new data to it, it's the same exact data set, but we are using a different program to work with the data so that the spatial dimension comes to light, and that is by analyzing it and looking at it in a GIS environment. That's what GIS is, Geographic Information Systems. And it is essentially a way, a database for spatial data. So it's not very different from some of these other programs. As strange as that might sound, it's not that different in the sense that it's also just a database for looking at data, for analyzing it, for exploring it, just like Socrata and Google Sheets, but it now has a whole new dimension to it, which is the map form. So today's lab will introduce you to data visualization and analysis in a GIS environment, and particularly we're using Carto. Just sort of picking up from what I was just mentioning, Carto, up until about 6 months ago or so, don't quote me on that, Carto is actually, the company called Carto is actually called CartoDB, and DB stood for database. So essentially that kind of helps us really understand that we're just working within a different kind of a database now. So Carto and other GIS software like ArcGIS and QGIS, which are both desktop software, whereas Carto is on the web, offer infinite possibilities for visualizing, mapping, and analyzing spatial data. The data you work with in Carto or another GIS environment has to have spatial information associated with it in order for it to be illuminated on a map form. So if you tried importing some data into Carto that did not have spatial information associated with it, Carto wouldn't know what to do with that data, and it would do nothing with it. So you might be thinking or asking, well, is all data spatial? And the answer to that is no. And there's in the lab, there is a sample table of data that does not have any spatial information associated with the data. So you need to sort of be on the lookout for whether your data has geographic identifiers in it. That being said, according to some studies that have ranged, I've heard figures ranging from 80,000 to 95%, I'm sorry, 80% to 95% of all of these newly available open data sets actually are spatial. So we think about the 1,500 data sets on the Socrata portal right now. If 95%, I can't quote this because these numbers come from studies that actually weren't about New York City. The 80% actually was about Brazil, I think, and the 95% was about New York State, not New York City. So I don't know exactly how many of Socrata's data sets are spatial, but I'm guessing and assuming and educated guessing that it is a lot. And that is what has led people to actually talk about us being in an era where there is like a deluge of spatial data. It's just all of a sudden we have so much data that's spatial. And I'd like to just mention that the very first time I took GIS was in 2007. And at that point, we had to like work to find spatial data. It was like a process to like figure out what data we could get that we could actually import into a GIS environment. I mean, I'm exaggerating a little bit, and people who were way more savvy or way more experienced with GIS back in the early 2000s, I'm sure felt that there was plenty of spatial data out there to work with. But for someone kind of new to the GIS world, I wasn't finding very much. I didn't know where to look. Now we actually are sort of in the opposite problem, which is that there is so much spatial data out there that it's making mapping sort of very easy on some level, but at the same time maybe a little less rigorous, because people are just sort of throwing data into maps without really maybe, thinking about it in all the ways that they need to be. So part of this lab is going to be getting you guys to really be kind of critical when you think about the data sets that you're planning to map and how you're going to do that. So just to kind of hit home this point, like in the previous weeks of the boot camp, we've worked with data that looks pretty much like this. And it has geographic information in it that we might be able to say, okay, so yeah, 20 East End Avenue, I know where that is. I can picture that in my head. The important point of that is you'd have to picture it in your head, whereas if in this new system that we're going to be working with, you don't have to picture it in your head anymore. You can actually look at it and say that's where that data point lies. So so we're moving from seeing data like this to seeing data like this. And that spatial dimension is very, very, very powerful and has always been since, my sort of studies go back to the early 20th century, 1920s, 30s, when some sociologists started to map crime and gangs in Chicago, actually. And it was sort of new at that time, to sort of be mapping these phenomenon. And basically, that was the Chicago School of Sociology. And basically, that opened up all new doors for thinking about policy, actually, for policy implications. Because once we could start really locating these phenomenon that were taking place in cities, well, then we had more power to think about how we could address these issues and what we might do to intervene to make things better and stuff like that. So, so that this spatial dimension of data in text form, sorry guys, the spatial dimension of data is very, very powerful, and I think it's really exciting that we're going to be working with it. So, so the lab objectives are to develop a conceptual understanding of mapping and spatial analysis. And why? Why did I spend some time with you guys just now sort of talking about all this background stuff rather than just clicking buttons? It's because you really do want to know sort of what you're doing and why you're doing it and how you're doing it before you just start clicking buttons. It's not going to sink in if you're just clicking buttons. And enough people out there are now clicking buttons because it's so easy to sort of do, because there's so much free software and stuff like that. So I want to give you guys a leg up and sort of have this background understanding of what you're doing so that you're a bit more skilled when it comes down to it. You know what I mean? So then, just as in the other softwares, we're going to become familiar with the Carto environment. That's number one. And then we are going to talk about the difference between spatial data in a CSV format and spatial data in a shapefile. It's sort of not worth getting into right now. The lab gets into that in detail. You can import spatial data into Carto in multiple ways. I'm just thinking about like how so we didn't need to import any I'm just thinking back to our earlier lessons. We didn't need to import data into Socrata, right? It's already there. All the data in Socrata is already loaded. You can't import more data into Socrata, can you? Not that I'm aware of. Now in Google Sheets, importing data is sort of just opening it. But anyway, whatever. Okay, so then we're going to learn some of functions in Carto, like the filter, which we've done many times over already, and people wanted to shoot the function filter in the foot by the time we finished last week. Well, we're going to be doing some more filters in Carto, seeing how that differs. And we're going to be creating two different types of maps, one called a categorical map, one called a Choropleth map. I'm going to get into that later. And then we're going to learn this very powerful data analysis kind of concept and tool called merging. And that will really open up doors for you in terms of data analysis. So I'm looking forward to having you guys get some experience with that. And then, because I'm like this census data person, I like thinking about people and stuff like that, we're going to do some people analysis, some census data analysis, and we're going to bring import census data into Carto and learn about some of these things like the GeoID field and the unique identifier and changing data type and stuff like that. But you'll get into it in the lab. So the lab sections are the following. It's basically just what I mentioned, but this is the order that we go through them. So first things first, setting up an account. So yes, you have to have another account. So yeah. When you begin your first map, you should have this interface, and I will be here today to make sure that this is the interface that you get. Several students actually did not get this interface. They got like a way more limited version of this, and I'm not exactly sure why, but some people switched email accounts, or someone signed up on GitHub and then signed up by Google and that worked. I'm not sure, but anyway, this is what it should look like. If it doesn't, call us over and we'll be able to help you make it look like this, because this is what it should look like. Now, once you get to this, okay, what's going on here, you might say? Well, it's pretty intuitive. You'll figure it out, but essentially, essentially with this is where you can toggle between viewing your map as a map form and viewing it in tabular form, and you'll toggle between those two regularly throughout any map that you're making. This here is where you add your data. So I think when you click on that plus sign, it comes up as add layer. So that's what they call it in Carto. When you add data, you're adding a layer. So in this frame here, we only have one layer, which is what this one represents, but when you have multiple layers, it's going to say 2, 3, or 4, or 5, and I think it stops at 5. And you can also not have a map with 0 layers. You'll never see a 0 in here. It always has 1. So this button here, you'll notice sometimes says visualize, sometimes it says publish. It's a little confusing. Just don't worry about it, but just follow the lab instructions, and basically when it says publish, that's how you know that your map is sort of saved and you can share it by copying and sending a link or embedding it or things like that. Anyway, don't worry about that for right now. This is where you title your map. You can save it that way. The back button right here will actually take you to your own table of contents of maps that you've already created and data sets. So that's a handy little button right there, the back button. Changing base map. Changing base map. You can change this base map to a different color, to having streets, to having other kinds of features on it. This thing that's shaded now, or not shaded, is called the map wizard, and that's very important. You click this button and something opens up and you can play around with your map and do different things with it. And this button here is called the filter, which we all know the filter from the other software that we used, and for some reason Carto has this other sort of icon for filter. Doesn't look like our usual filter icon. Remember that filter icon that looks like this? I don't really know why, but I guess it's just doing it a little bit differently, but it's the same basic idea. So that's kind of the basic elements. This is where you zoom in, of course. Here is where you zoom in, yeah, you'll get familiar with all of this stuff. So adding data, that's probably one of the most important things to do right away with Carto. This is the lab will tell you how to do it, but we're going to be mainly doing it through a data file, which is where you browse for the data on your computer and connect to it that way, or you can actually connect to data through your Google Drive, so you can experiment with that too. Okay, so this is an example that the lab will take you through of mapping the Knowles data set from last week, the 38,150 row data set just from Community Board 8. So when we import that data into Carto, it takes us from just that big table, scrolling down 38,000 rows, and it actually shows it to us in this form. So it has mapped these points by its latitude and longitude. Now this is a very simple map. It's not really telling us anything else about the data, whereas when we create a categorical map using this little function in the map wizard that I mentioned, we can categorize our data by, in this case, zip code. So, and many other types of things. So filters, this is the icon, and there's 2 different types of filters you can do in Socrata, both a numeric and a text filter, and you'll see that those are quite different, and I hope that you sort of spend a little time thinking about that. In the lab, we'll do a text filter by agency, and we'll do a numeric filter by zip code. So the deliverables for the 311 analysis part of it is going to be doing some filters and making some category maps. We're going to categorize our data according to agency name. We're going to add another filter, export to CSV, count the rows, etc. And then open the CSV like in Google Sheets or something and see how many rows are in that data set. Because I actually think it's a bit easier to count the rows in Google Sheets than it is in Carto sometimes. I don't know. Anyway. So remember how I mentioned in the earlier part of the lab, or an earlier part of the lecture, sorry, that there are two main types of spatial data that we're going to be working with at the course of the lab. The CSV is a table of data that has to have latitude and longitude. Well, does it have to? Yes, yes. It has to have latitude and longitude in order for Carto to map it. Whereas if you are using this other type of spatial data called a shapefile, which was a format for spatial data that was sort of invented in the 1960s when ArcGIS was first founded. It is a format, a popular, now like a very popular format for spatial data that gives us this geographic, spatial information that we can actually see according to its shape. So shapefiles can represent points, lines, or polygons. And in this map, we have it representing polygons, which are the census tracts in Manhattan. So we're going to work with two shapefiles in the course of this lab, census tracts and CDs, and they're referred to as CDs in this lab, even though they are akin to our CVs, and that's because, as you might remember from one of our earlier weeks, that CDs, when it comes to the geographic extent of them, community boards are called community districts. And so since we're working with the geography of community boards, they're referred to over the course of this lab as community districts. And then table merges, as I mentioned, is a very powerful tool in data analysis. It's based on a common field between two tables and a unique identifier that permit us to link data between two tables, and all of a sudden have like a way bigger data set that now has two tables worth of information that is linked by this common field in the two data sets. So hopefully this will become clear to you as you go through the lab, but I'm going to just show you an example of what I mean by that. Here we have a CSV of demographic data, actually. As you can see, we have population here, median age, but it also tells us what census tract it's in by this identifier called the GeoID. Here we have our shapefile. Like if we toggled onto map view rather than data view for this, what we would see is this. Okay, so this is that data in map view. When we toggle over to data view, this is what we see. And it too has a field called GeoID that has the same kind of information, a unique identifier for every census tract. So using this common field, we can merge these two tables, and the information for this census tract will find wherever that field is wherever that row is in this data set, and appended to that row of information in this data set, you will now have the other data that this data set has. That's something you could probably do on your own if you had a data set of like 5 rows or something. You could say, okay, let me type in the rest of this data about this one particular row. I have this data that says this, now I have more about it, I'm gonna just add a new column, add a couple new columns. Well, when you're working with a data set with 13,000, 38,000, 13 million, 14 million rows, you cannot possibly do that kind of work yourself. Only a machine can do it, and in fact it can do it in about 5 seconds often. It can link every single unique row to each other, and if you have these common fields, and give you all this new information about it in one table. So, so anyway, that's what the table merge is going to enable us to do. And we do that in Carto through this function called column join. And this is what it looks like. And there's a screenshot of this in the lab when you get to that point in the lab. And it should be good. It's a good thing to do. And okay, so it's not over quite yet. One thing I'd like to mention is that sometimes, or oftentimes actually, when you import a CSV or a shapefile, no, maybe not a shapefile. Anyway, when you import a CSV into Carto, it will actually change the order of your columns. So say you had a data set that you liked the way it was structured very much, like here. You know, I have my ID column in my first column and my GeoID next, and I have total population in column D, and you've organized it in such a way that makes sense to you. Well, sorry, but when you import it into Carto, it's going to change the order around. It's going to alphabetize them, I think. And so you just have to kind of deal with that. But and it may also change the data type in that column, but it makes it very handy, very easy for us to go back and change the data type to what we want. So for instance, in this column here, this is numbers. I don't want this data in quote unquote string, which means text. I want it in numbers, so you click change data type, you click number, and it does it for you very easily. So anyway, there's things that happen sort of in between these processes, but there's ways to deal with them. So Choropleth is the final thing I want to mention, and a Choropleth map means that it is a map that shows us predefined regions. Whatever those regions are, they can be as small as a census block, they can be as big as a country even, or a continent, that are shaded in proportion to the measurement of something that we are looking at in the map. So it provides a way to visualize how a particular phenomenon varies across a geographic area. So I'm going to show you a picture of one such map. This is a Choropleth map, whose predefined region is the census tract, and it is shaded according to a percentage. I think in this case, this map is shaded. I didn't title my legend, but it's shaded to the percentage of Black or African American population in New York City. So we can see that the much larger percentage of Black or African American is in Harlem and some of these other areas. Central Park is an aberration, obviously. That needs to be cleaned. That data set needs to be dealt with. So that Central Park shouldn't be on this map or something like that. But anyway, so basically it shows the variation of this particular variable according to a region, a predefined region, which in this case is the census tract. And in the lab, I point you guys to explore some other Choropleth maps on Google image search to see that these are some other examples of Choropleth maps. And essentially, as I said, they all use a region, a predefined region, and they color it accordingly. And it's a very, very, very popular and kind of foundational way to map data. Oh, am I in the wrong? Did I go to the wrong? Yes, I went to the wrong thing. So that's the last thing you're going to learn, and that's it. It's long. It's 28 pages, but it should be good, and it should be. I think you'll enjoy it. Someone said that it's a lot more sort of fun to be able to kind of visualize and make different colors out of this data and stuff, instead of just like looking at it as black and white text over and over and over and over and over and over again. So, all right, that's it.
Okay.
Okay, great. Thanks, Malik.